Okay, we have 2 days till the solar eclipse. I think maybe group picture next week, just because it's not a lot of people. So we'll take one of the awkward pandemic group photos where everyone turns on their camera and we just get scores of people.
Mm-hmm.
But I do want to point out, I've already set up next week's minutes in case anybody wants to share any particularly good eclipse pictures or grape eclipse pictures. I think most of this is backlog. And is there any, I don't know, hardware through documentation issues that could be considered urgent for tomorrow? Or not tomorrow, for the weekend. I'm losing time already.
Can you enlarge your picture a little bit there, Rachel?
Yes.
It's an eye test. And I'm failing.
Yay.
Thank you.
Thank you.
Okay. So I think we're all good on that. For the most part. Rape stations. I don't think, is Gary here today?
Yep, I'm here.
Okay. Did you reach out to any stations not currently uploading in the database?
Yeah, I did. There were only a couple, and of the 2 or 3 that I reached out to, I can't remember the details. 1 or 2 have since come online, and so there's maybe 1 or 2 that we've not heard from. So I that was kind of to be expected. You're never going to hit 100%. So
Yeah, and I had these numbers from a few days ago, but for the most part, our map is looking pretty green.
yeah, one of those just arrived is on the call with us today. Dave W0DAS. Thumbs up to Dave for getting his one of our control stations because he's so close to WWV. So kudos to Dave.
Okay. The old control station.
I see Jim Farmer's station submitted data last night at 0 UTC. There's only a
Yep.
partial observation, but it's running.
Yeah, I got it running, I think about 6 o'clock Eastern Daylight Time yesterday
Perfect.
evening.
Perfect. Congrats.
And it should stay up from here. I hope.
Yeah, that's great, Jim. It shows a 2-hour upload, so that's exactly right.
Yeah.
Right. And the only station I see that is in the orange is Kilowatt Delta 6 Oscar out in California. His station was working for a while, but didn't upload anything last night.
Yeah, he thinks he has a great. I'm not sure if Art's on there today, but he had a Grape 1 failure, he thinks. So if he's on, we should try to help him through that.
Yes.
Yeah, thank you. I put out a distress call on the list, and Robert, what's your call sign? Here we go.
Do you need to share your screen?
AE5 Yankee Golf has shipped me another unit, which is due to arrive this afternoon. So hopefully I will be back in the green shortly. I went ahead and stopped the processor because I didn't see any point in uploading a bunch of empty data. But I am guardedly optimistic that I'll be back in time for the event.
So your system, Art, I guess, for lack of a better term, your Grape kind of went flatline, right? There was no more output from it.
I was getting a a stochastic sort of flat line at about 120 dB down. And I could disconnect either the antenna or the local oscillator, and it didn't change a thing. So I am reasonably confident that something happened to that grape, but we'll swap that in. The rest of the chain seemed to be working well, and right now I'm struggling to get new radio running on another Mac so that I can take a wideband recording contemporaneous, so that we can maybe disambiguate some of the WWV, WWVH overlap.
Okay, well, it's good to hear that you may be back on the air this afternoon. That'd be outstanding. And then if the Grape 1 really did fail, hopefully we can, after the eclipse, we can do an autopsy and figure out what happened so we can learn from that. Because the early Grape ones had some lightning issues, and John since improved that. So we'll have to see.
Okay, I haven't spent any time even speculating. Probably my fault, but at this point, I don't have a theory.
The only quick thing I could suggest is make sure that your Leo Bodnar frequency is set correctly, because that would cause a flat line. Although you'd still get 120 dB down tells me you're not getting any RF input, so who knows? It could be very well a mixer chip. That's about all it could be.
And I had seen it put out a healthy waveform earlier, and then it kind of came and went over the course of a day or so, and then it went.
Yeah.
Could the transient suppressor have shorted?
I'm sorry, say again, please.
There's a transient suppression double diode at the front end that could have shorted.
Could be.
Yeah, that can happen. Easy to check.
Well, yeah, one good thing, Joe, W7LUX is offered to help and repair and that sort of stuff. So if worst comes to worst, we'll hopefully maybe we can get the board to Joe in the next couple of weeks and we'll figure it out. So it's a learning opportunity. Nothing wrong with that.
Yeah, it's probably only 2 or 3 different parts that could cause that, so it should be an easy fix.
Yeah, my address is good in qrz.com.
Very good. W7LUX.
Okay, and I'll mention, I'm sorry.
This is Mike W8ITKK. Joe, did you get your email thing fixed with that routing through AWRL.net?
Nope, and other people are having problems with that also, so it's not just me.
Okay.
Anyway, that's not a very reliable thing. But anyway, the address is, well, if anybody wants it, Nova, N-O-V-A, at npgcable.com. That's November Papa Golf Cable.com. And I'm going up to Utah, so I'll be back probably Sunday.
Okay.
Yeah, and this is I just thought I'd mention again to get it on the list here. I'm waiting for a response for my request for a note number. I sent it in a couple days ago. And at first I sent it in, it was not correct. So then I sent it in again where I got the file. I found the great instructions. These instructions are great, by the way.
Oh, thank you.
So I sent that.
You'll get that this afternoon.
Great.
I'm kind of buried, but as you might have guessed, but I try to do them in the evenings if I don't get interrupted. But
okay, well, I figured that was it. But
yeah,
now that I've got it, now that I've got it displaying a nice vertical line on my VNC, I really want to.
Yeah, we'll get you going.
Contribute to the cause here.
We'll get you going. Apologize for the delay.
Oh, no problem. I just don't want to get lost here.
Okay. Any other, so try to stealthily take attendance here. Any other,
Just a suggestion, Rachel. Why don't you put a date on that nice map that shows all the green?
oh, because I take one every week, and
Well, it's kind of,
I'll probably remember what day it is because I take the screenshot fresh.
we could get into that, but I mean, if this is the record of the minutes of us meeting, let's put a date on that. As
fair.
a kind of,
That's a European date stamp.
Yeah,
yes, it is.
It makes sense to permute the order, and I think fine. I will spell it out.
No, that's fine. Leave it the way it is. Just giving you a hard time.
just showing our sophistication.
You're overdue for being given a hard time, so I'm trying to catch up.
Thank you.
All right. For the record, I take one every week. So in previous minutes, it's just if there's a picture, it's from the same day. And
Uh-huh.
Okay. Any other current Grape 1 deployment issues, testing, questions, emergencies, blights? I don't know. Are there pests that feed on grapes? I don't know.
I just have a quick question. Right now,
Sure.
I'm set up to monitor 15 megahertz. Does it really? And the reason is because I've got so much 10 megahertz running around the shack, that would be worthless unless I turned off my 10 megahertz. So I hope that's going to be useful for this this weekend. Go ahead.
Yeah.
Well, we're targeting 10, but you might try, well, 15 would be a possibility, is probably the next best one for during the day. So you're probably all right. Because I think 5 disappears during the day, and I don't think there's going to be enough reflections to get anything on 5, although 5 would be interesting if we actually got something during the eclipse. But
Well, my hope is that at 15, I probably won't get the Hawaiian station as much. And I did see it come in this morning at 7 in the morning, my time, and the eclipse is 9. So we should have
Okay.
a nice signal by 9.
yeah, 15 is probably the best alternative.
Yeah, that question came up from a couple of other people too, and Nathaniel agreed 15 is good, so I think we're all on the same page.
Good thing I added it to version 1.12.
Your timing was excellent.
Yeah, I got lucky.
I even asked about using 20, but I was told that that would be rejected. But 20 is good because WWVH, as far as I know, does not transmit on 20.
25 is also good.
Yeah, if it's on the air.
It is on the air because we've been receiving it for the last 2 years, but
Oh, cool.
we're doing a different experiment. David Kazdan's doing the second tick monitoring, different project.
Okay. I thought I'd mention that because I noticed when I tuned up to 20, I heard WWV real fine, but there was no female announcer. I said,
Yeah.
Finally got rid of her. I don't mean to say that in a nasty way.
The physics of the atmospheric research wants to stay down below 20. I think that's where Nathaniel was sort of headed in terms of with his frequency picking. So
I mean, the general philosophy is
there he is.
hi, yeah, sorry, I was out getting provisions in case a lot of people happen to come by my house during the solar eclipse QSO party this weekend. I'm uncertain if that's going to happen, but so I think the general philosophy I had was try to have as many stations collecting the same frequency as possible, because that makes the data comparison easier, easier. However, I think it should be left up to individual stations to kind of make judgment calls. If you have a lot of 10 megahertz running around in your shack and that's contaminating things, that's a good reason to move to a different band. If you're in a location that doesn't receive WWV on 10 megahertz or on 5 megahertz, but you get it on 15 megahertz all day long, go to 15 megahertz. I think what's going to be really nice at the end of this is that we're going to have a rich data set with many different observations from many different people. And in the process, in post-processing, we're going to look at the different things, and we will find that some of the data is going to be really nice and give us really useful results. And some of the data may be, contaminated, or someone's system may go down or whatever, or maybe we're going to decide just to not focus on that particular frequency at this time. And that's all okay. I think, there's going to be a lot of stuff to work with no matter what.
There's going to be noise in this data, but there's going to be a lot of data.
That's right. And there will be signal too, because I know Bill Engelke sent me summary plots of all the stations that were uploading on October 9th. So he sent me, I can show them if you want, or Bill can show them. But there was a lot of nice signal in there. So I think we will get something really useful out of this.
Yeah. Pending no other grape themed emergencies, I would love to see those plots.
You would love to see the plots. Okay. Why don't you give me a minute? I didn't have them quite ready to go.
Are there any other grape themed emergencies?
We actually do have them.
Yeah, any grape stations currently not operating or having issues? Now would be the time to speak now, or for at least the eclipse. Hold your peace.
It doesn't have to be done for the eclipse. I have a magnetometer question sometime, but not urgent.
Well, we might as well
Okay,
take.
I have the data ready.
Okay, go right ahead.
All right. So Bill Engelke sent this to me a couple days ago. Let's see, I have it right there. See if I can open.
wait.
Ooh, shiny.
Yes. I'm gonna see if I can get my computer. Yeah, look at that. My computer opened all of them at the same time. So Bill does have the ability now to go through and make these summary plots on a daily basis of everyone who has submitted data. And I know their team is working on a way of having the server system automatically produce these plots and make them available to the users as well. But that's in progress. But I can just flip through this. This is from Bill's Grape station. You can see generally we have really nice observations through the night here. You see evidence of mode splitting. Go down. See, this is my station here in Pennsylvania, which I just got running the other day. And you see some really funky stuff going on over at dawn over here. This is station Grape 32. I don't know who has that. We see a little bit of noise in the station there. We are, let's see, I don't know what their longitude is, -93. I'm guessing this is daytime over here and this is nighttime. They're seeing quite a bit of variability there. This is Stan KD1LE. It looks like he's seeing the same funky sort of feature in dawn that I saw at my station, so that's kind of neat. And here's Grape Station 11, same sort of. Yeah, so actually that day there's
Yeah,
really
11 is mine in Macedonia.
Oh, great. Yeah, so all of these East Coast stations saw this really interesting, kind of flare up in the dawn hours there. This is George's station, I believe.
Yeah.
N4 TVC, they're all, so this is great. I mean, this is beautiful. One of the things that Bill Engelke noted that I'm not sure if you had a chance to talk about yet, or we have to figure out is we do see these periods in some stations where there's a sudden drop off in amplitude. And you can see like here in the middle of the day, just all of a sudden whoop, down in amplitude and then here down again. And we haven't, had a chance to figure out, is that something that's an instrumental problem or is that a space weather thing? Like there was suddenly a solar flare or something. I don't know. The nice thing is, even if you do get those amplitude dropouts, as long as you do have some signal here, the frequency seems to be tracking appropriately. So I think we can still get useful measurements even from the stations that have the dropouts. There's a Bill Blackwell AB1XB. So yeah, I'm happy to report that it looks like okay, N2IC looks like they're having a little bit of trouble there. But in general, it was really nice that Bill was just able to go onto his system, produce these the next day, and we have some really nice things to look at. So I'm hoping that
Yeah, that one with the complete blue or yellow background, that looks like it's an overmodulation if you go back a few.
Yeah, that's Steve in New Mexico, N2IC. I wonder, I mean, he's got a lot of transmitters and a lot of antennas. He's a big time contester.
That looks like he's overloading the front end is what it looks like. It's all over. It's just that's a shotgun.
Detected at the front door.
But I think this looks, what I'm seeing here, I think looks very usable. And I think I would expect to see some sort of nice eclipse effect. If Bill, as soon as Bill is able to plot these from Saturday, I think very quickly we'll be able to be like, hey, look, there's the eclipse. That's what I'm hoping anyway.
Great.
So yeah, everyone just, if you have your station going, just keep it going. I wouldn't worry about these drop-offs for the moment. Trying to fix that, I think, is going to cause more trouble than it's going to help.
Don't touch anything.
Yeah, we're getting nice. These are very, very nice results. So I'd like to congratulate the entire team on all of their hard work to get to this point. It's really amazing.
Absolutely. The students had something ready to go to start the plotting. They had that ready on Tuesday. Said, no, the system is frozen until after the eclipse. So we're going to be putting on a bunch of changes and fixes next week after we get the data from the eclipse. Yeah. We're not going to fix anything between now and then. That's not an emergency. Break fix we'll take care of, but no enhancements or bug fixes.
And Bill, maybe you can, we don't see your students on this telecon very much. So, perhaps people aren't aware of them. Maybe you can say a few words about your team and how much they're doing, because they really are doing a lot and everyone should be aware of this.
Well, this project is by far the most interesting project that computer science department is working on with their student projects by far. And, they won the poster competition last year, so news of it has got around. So what Dr. Atkinson is able to give me is the two top students in the engineering honors program to work in the CS, because CS is part of an engineering department at UA. And so one of our students who
We're losing you, Bill.
We lost you.
Sudden amplitude dropout.
That's probably Starlink at work.
There you go.
It comes and goes a little bit. One of our students, Nicholas Muscolino, graduated last semester, so he's off the team. But we do have a new student named Evan, who just joined, and he's coming up to speed mainly on Django, which is a platform that runs the website. So maybe we'll get a chance to get them to come to one of the conferences. I hope. Wouldn't that be good? Maybe
I think that'd be really great, because
where is the HamSci conference going to be in the spring? Has that been decided yet?
Yes, it's going to be at Case Western.
Okay, good. Good. Hopefully we'll get a chance to get the students to I'll start talking to them now so they won't make spring break plans.
Good luck with that.
Who wouldn't want to go to Cleveland on their spring break?
Cleveland is a wonderful place.
Well, I mean, I lived in that area for 12 years, so I'm familiar with it. But yeah, they can go down to Gulf Shores for the first part, and then get a direct flight from
There you
Panama
go.
City or Mobile or somewhere up to Cleveland if need be.
I think that's great.
But also, did you notice we've got a station in the Netherlands now reporting data daily on CHU? He's monitoring CHU.
That's awesome.
Right. Is he on the map?
Yes,
Yes, he is.
Yes.
And he says he's been contacted by another amateur in Poland.
Oh,
who runs
yeah.
a system in Poland as well. So the two of them are working together.
PA0 RWT.
Yeah, and they're homebrewing. They have these software-defined receivers, and they're setting them up to make Grape compatible data, and it's doing a fine job. So we should have some more international participants here pretty soon.
Excellent.
And that's right. We are having some people work on making seedless grapes, or grapes that are grapes without grape hardware. Michael Howen is one of the people who is working on that effort. And so I know he's going to be recording, I think he's in Missouri. I think he's going to be recording wider bandwidths in most of the grapes this weekend. So he'll be able to identify if it's WWV or WWVH. And as you know, after this weekend, I think he's going to probably work with Bill on figuring out how to get a seedless grape system to also be able to upload to the database.
Well, on that same note, I'm running a Grape monitoring 10 megahertz, but I'm also I've set up my Flex radio to produce a Grape compatible output, and it's reporting on 15 megahertz. So we've got a way to make a Flex radio produce Grape compatible data as well, DRF.
A little bit of a pricey grape.
Yeah, well, I mean, the thing is, you can leave it. I'm also running a couple of channels of FT8 on the system at the same time, and it works.
True.
It just
How hard is that to install the software build? Is that running under Windows?
Yes, it's a bear. I don't have it completely.
Oh, okay. See, I've got
completely debugged yet, but
I got a 4-channel Flex 6500 I could dedicate to that, but if it's not something that's trivial to set up.
well, I hope to get it to the point where it's something we can hand out.
Okay.
I'm trying to do it. I mean, there are certain things that you can do on Unix with Python. You try to do it on Windows, the system just ignores it. So
Yep.
I've got to work around a few things on that. So that's coming along.
Nice. Thank you.
Okay. All right, I guess this is the last chance for Grape 1 related questions, comments, or concerns, or any Eclipse stuff.
At some point, I'd like to go over some changes to the Grape 1 web pages and whatnot, but that's not critical, obviously.
Yeah. Well, at this point, we're only at the 30 mark and we're done. It seems like we're done with critical. So if you'd like, we can do that today.
Can I speak to George Kavanaugh for a minute?
Sure.
Great. Hi, George. How are you?
I'm well. How are you?
Good. I don't see the email you sent me back.
I'll
So
send it again.
I just sent it. I re-forwarded you the email that I had sent before with the form. So
Yeah, I just got it. The one you sent before did not have the form attached.
well, I guess something in the internet is I don't know. So yeah,
Well,
if you could kindly
we'll work this out today.
thank you. Appreciate
Yes,
it.
yes, sir.
And I see Layden has her hand up. Back to Net.
Oh, I'm sorry. I was not even looking at hand raising. Layden?
Hi, sorry, just wanted to, if it's okay, introduce myself. I'm from Time and Frequency at NIST in Boulder, Deputy Division Chief here. Very interested to have a recording here. I wish we could have started earlier. I just bought the SDR and different things to put together here, kind of further away from campus in North Denver. So I just wanted to introduce myself and say I know I'm probably late. I would probably need some support to put things together because my background was actually in atmospheric sensing and air lasing, high power laser in the systems, and dealing a lot of, or how can I say, like spectroscopy even in air. So I'm going to a very low frequency, I understand, but I'm very interested in analysis of the chirp pulses and their modification through atmosphere. So just want to say I'm a friend of us send me this link and I'm very happy to join and I would appreciate your support. Thank you.
Welcome aboard.
Yeah, you should mention to her that there's a rumor there's a group photo next week. You probably want to join us and be in the group photo.
Yes, thank you. I got Aiden, who's in my team also. Yeah, she mentioned that this group is there and we can get some support. So I appreciate that. Thank you.
We're very, very glad to have you.
And we're very, very glad to have NIST Time and Frequency Division.
Yeah, we'd be kind of lost without you.
Yes.
I think it's a shame if we don't record. That's how I feel about that. Thank you. Especially from I'm from Time Distribution and Dissemination Group with the WWV and WWVH.
I was thinking this morning, I saw news that the Canadian Broadcast Company is not sending their time signal out over their I guess like public broadcast. CHU is still running, but that signal is not being sent anymore. And they said that was the end of an era. And I thought that was very sad. And it also reminded me how important it is for this project and what we're doing to have WWV and WWVH working. So we're very, very grateful for NIST support and for running the WWV and WWVH radio stations.
Oh, we are having some challenges here in terms of our band and broadcast. There are companies who would like to take over those frequencies that we are broadcasting right now. You mentioned CHU. Just want to say that previous to here, I was actually working in NRC Canada, time and frequency, and also CHU. But mostly, I'm an optics person, so radio frequency is a bit. I need to adjust myself with that speed. But yes, I've worked both in time and frequency and time, NRC Canada, and now time and frequency, NIST Boulder. Thank you.
Thank you. Well, if there's anything that we can do to help sway public opinion or whatever to keep WWV and CHU on the air, we will do it.
Yes, that's exactly why I'm here. Last few months, I was working on an update of our web pages. I'm working with public affairs in terms of, and we have science writers. So we are trying to really do that public opinion. So yes, I can send my email here. I would like kind of support in terms of hardware and software and everything that I have to get up and running to provide data and then later probably communicated with public and with our division, because we have challenges honestly to get the system running because I told you, like companies interfere, they would like to get the band, they would like to get access to things that we try to have kind of only belong to NIST. So yes, I will drop my email in the chat. Anybody would like to help, I appreciate that. Thank you.
Okay. I'm going to share back to the minutes. I think at this point, we are done with Grape 1. Fingers crossed. If anyone thinks of any emergencies before the end of the call, you're welcome to take back over. I'm going to get some Grape 2 updates. John,
Okay. Can I share my screen?
Oh, absolutely. I take it that means that there are new Grape pictures.
We have a major milestone that happened Monday or Tuesday. Let's see here. This is a screenshot of the Grape 2, and that is showing the directory of the raw data collection of a live 3-channel radio collecting real data and storing it in the correct format to a file every hour. Each hour's data takes 432 megabytes, which works out to about 10.4 gigabytes per day uncompressed. That does not include the couple of megabyte files for the time correct or the time derivation of each one of the 3 radio channels, but that's coming. But Kung and Bill have made the major breakthrough of this is actually collecting on the fly in real time and keeping up with the fire hose of data coming from the Pico that's reading the radio data from the A to Ds from the raw radio channels. So as you can see, it ran for a day, collected the data correctly, and the files are all correct, and the formatting is correct, the headers are there. As per my file spec, the files, again, are still standalone, so if these get lost, if you just look at the beginning of the file, you know exactly what it is, exactly what it recorded, when it recorded it, and what it is. So, but this is the compilation of the 3 radios into one raw data file, which is where this is the 8 kilosample per second raw data file for the 3 radios. But it is working, and like I say, it's a major breakthrough. Now I'm in the process of trying to break this in that Bill has already kicked the data sampling rate up to 10 kilohertz from 8 kilohertz, and it still worked. Now he's giving me the tools to see how far I can take it, to see how much headroom we have on the USB bus. It's a work in progress, but like I say, this is a major breakthrough. This is the whole chain working all the way to the solid state drive. So like I say, this is a major flag of accomplishment. Again, my hat's off to Kung and to Bill for a phenomenal job. They're still smashing bugs left and right, but we're getting some good progress here. And this is something that should be noted, that we've accomplished it. So that it is, this basically says, finally, the Grape 2 concept works.
Hooray.
Yeah.
Hey, congratulations, John.
So
you've crushed the grapes and made the juice, so now it's ready to ferment. Is that it?
exactly. And I'm thirsty.
Congratulations.
Now it's time to plant a crop of them.
Yep. I also sent a couple of pictures to Gary of the development stuff. I was hoping you'd throw that up on your little rotation screen of pictures on the website.
You mean on the very front page of the Hamsci homepage?
No, basically that there's one for the Grape one, I thought, or Grape development or something.
Okay, I'm not sure we had another one, but I'll find it, and if not, I'll find a good way to use them up there. So
yeah, but it shows it for people who are technically oriented. It kind of shows what I'm using for tools and what everything looks like, and I thought they might be interested in seeing that. So
no, they are good pictures.
So let's see, what else have we accomplished? I was talking to finally the correct person at Tapper about the magnetometers, and the way it is set up, the way Scotty left it, is you can only buy the board sets as pairs. They want $120 for the board set. But the problem is I've got the Grape 2 interface already has the local interface to talk to the magnetometer board. So I can't use it because I'm already using the 40-pin header. So I still have not gotten correct communications with the magnetometer yet. Dave Witten is going to be writing me some Python code to be able to do some simple testing so I can actually see, because I can see him on the I2C query of the bus, but I haven't been able to get past that.
So I have a word about that. Scotty has essentially left the project, which I think many people know, and he has basically just not been, we can't communicate with him. We cannot reach him at all.
Oh, wow.
Yeah, it is just not possible to reach Scotty, which has been very difficult. At the same time, we have been working, we have changed direction on the Tangerine SDR project significantly. We made that change starting at the Dayton Hamvention, and that has also changed a little bit of our tack on the ground magnetometer as well. So Dave Witten has been very reliable. and has been very good to work with. And Dave Witten also has his, his design of the ground magnetometer that that Scotty basically based Scotty's version off of. So right now, Dave Witten is working on cleaning up those designs, and he's working with Hyo-Min Kim to write a paper for Hardware X with Dave Witten's designs. The intention is that we want to sell out whatever's in Tapper's store right now. We want to get those magnetometers sold out. But once they get sold out, we would probably replace those with Dave Witten's design. So what you might want to do is talk with Dave Witten, and since you already have the local end, perhaps he can work with you just to get the remote end of his design, and you make it work with Dave Witten's design. And
I was thinking about just knocking out the board that's basically the Rev E, because that's pretty straightforward and there's not a lot of parts on it. The RM3100 is the most expensive part, so.
What do you mean by that?
Make our own boards.
Instead of
because I'll work with Dave Witten on that, but I mean the board layout is already done.
Okay, well, why don't you see what why don't you talk to Dave Witten and see what seems to make sense with
I'll
him.
work with Dave and see what's going on with that.
Okay.
I think we can make this work.
Okay. Yeah, I think that would be good. Dave Witten seems to be good to work with, and yeah, that sounds great.
Yeah, even as we speak, he's writing some test code in Python for me to be able to query the 3 sensors on the I2C, about the 2 temp sensors and the RM3100, because I'm talking to all of them. It's just the program just refuses to get past. It looks like it's waiting for a ready bit, is what he thinks it is, and he doesn't know why it's hung. So we're taking a step back, writing some diagnostics, and we're just going to query the things to make sure we can read the registers and everything looks good, which proves the hardware interface, and then it's just software.
Yeah, that's it.
My apologies to Bill and Kung. They're going to shoot me, but I'll get that later.
Just software.
Consider yourself pre-shot.
Let's see what else is going on.
So real quick, on the existing magnetometer, is it going to go obsolete with this new one or not?
It shouldn't, because the addresses that I'm using were the ones he had on Rev D. Now in Rev E, he moved the magnetometer from hex 23 to hex 20. What I may do on the board is just make that a jumper option. We'll have it default to whatever we decide to keep it at. Because right now it's really not standardized because nobody's really using it. The local temp sensor is at address 18. The remote temperature sensor is at address hex 19. And the remote magnetometer is either going to be at 20 or 23. So I don't see a big issue of keeping the existing boards working. I don't see any reason not to. I mean, there's not that many of them out there, but we don't want to cause people to have to go out in the backyard and, dig up the magnetometer and change the board. That just seems silly.
Yeah, I just got mine buried a couple of weeks ago.
Exactly. I just got mine put in 2 weekends ago. And like I say, I've been trying to talk to it. I can see it on the bus query, but I can't get Witten's program to talk to it yet. Like I say, it's hung. I put a logic analyzer on it, and it's hung in a loop of querying address 2034 and looking for, it's getting back a 24 back, and it's telling me that a ready bit isn't not being set. So it's waiting for the magnetometer to come ready. So I'm not sure what's going on, if it's not getting set up right, or if I'm not talking to it right. But I sent Dave my schematic for my interface this morning to have another set of eyeballs look at it. But the remote interface is very, very straightforward. And being that I changed the ID of the hardware for the RM3100 in his program, and as soon as it fired up, it read the program register or the ID register from the magnetometer. It got the number it should have given, and it conflicted with what I changed it to. So it complained it wasn't the right hardware with, and it exited out. So I know I'm reading the registers in the magnetometer correctly. It's just there's something silly that I don't know enough about the exchange protocol yet to figure out what's going on. So he's writing some diagnostics for me. We'll get to the bottom of this, because that's going to be the next project for Kung, is to read the magnetometer. And because we've got a file set up already for the magnetometer data on a once per day, and that these 3 files with the frequency determination, and then the 4th one will be the magnetometer data, will all start getting uploaded to the WWV ARC database once we get the Grape 2 running. And the other note is, if you do the math on 24 of these 432 megabyte files, it works out to about 10.37, about 10.4 gig per day, times 365 days works out to about 380 or 3.8 terabytes. So a 4 terabyte drive will last us basically 1 year of data collection, which means you should probably within that year buy a second set. And then at the end of the year, we'll do a swap exchange and get the data back. And I'm not sure, Nathaniel, what you want to do with where we're going to put this, but a 4 terabyte drive will last us 1 year's worth of data.
Okay.
Well, here's something to consider. Nathaniel has a server with many terabytes of data on it. If we can figure out a way to load the data up to the server, it wouldn't have to keep it locally. Wouldn't have to keep all of it locally.
Okay.
So that's one thing to consider.
Yeah, I think the raw data is probably the most important one, because that's going to allow him to do future experiments on things we haven't even thought of yet. Because he's got the full spectrum, it's all there, it's perfectly time synchronized. This will support future research.
Did you say that's that 4 terabytes, is that compressed or not compressed?
That's not compressed.
Okay, so we will, if we use a lossless compression, we can do much better, I think.
So if we had, say, a 50% reduction in size of these, it'd be 215 megabytes per hour.
Yeah.
That's almost uploadable in real time, but with 50, 60 stations doing that to a server, I suspect that's going to be a major overload.
Well, one of the things we have to do is, with the Alabama grant and, the first Grape grant was funded on the idea that we were doing prototypes. I think we're starting to get out of the prototype phase.
Yeah.
And I was talking to Bill and Travis Atkins and his PI yesterday, and I was saying it's about time for us to think about getting more funding for Alabama. And I think part of that, knowing these numbers and, trying to figure out how this works, that'll probably help get them more funding and get us more space.
One of the things that you can do is, if you have the right funding, and we can get funding for this probably if we make a convincing case for it, and the powers that be believe in it. You don't necessarily have to use a local server. You can use Amazon Web Services or Azure or one of those big systems, and there's almost unlimited storage, and to just store data is fairly cheap. They just charge you for moving data in and out of it. So that's one thing we can consider too, uploading to Amazon Web Services, and they have unlimited capacity.
We'll test those limits.
So I think, I think there's a way forward here. The important thing will be figuring out, getting right now, we just need to get the prototypes working right, and then we're gonna work out how we get more support and where to put all of this.
The other hardware update I have for Grape 2 is that since we are now actively collecting 3 active channels from the RF deck correctly, that means I can now pull the trigger on getting the boards made. So I'm going to start engaging a couple of local board houses on the production of these boards, get 50 of them made. I've got the parts and everything for all of that, headers and stuff. I got all the expensive stuff. So I just have to have some communication with them on what fiducials they need for optical sensing, and if they need pilot holes to hold the board for the silkscreen process. So I've got a solder fixture set made already from actually hand soldering the connectors on the board, because they can't do that automatically. And I'm going to have to sit down with them and go through production procedures, and then I have to come up with some production file test or hardware test fixtures to test these things. So because you just don't make them and they work. On a first production run, it's been my experience at Keithley that if you're doing good, you get a 60% yield. After 3 or 4 runs through the production line, you can usually get your yields up above 90. But there's all kinds of things that can go wrong. It's something as silly as somebody populating the wrong reel on the quad machine, which does the pick and place, and you put the wrong parts down. But sometimes you can find them, but bypass gaps are hard to find. But for resonant circuits, if you put a capacitor that's 10 times the size it should be, obviously it moves the frequency by the screw rate of 10 off and nothing works. So that's the kind of stuff you have to catch in the testing procedure of when the boards come off the production line. So it's all a work in progress. We're making progress. And also, if anybody has any experience with doing production tests, please get a hold of me. I got a job for you. Back to Ned.
Okay. I assume too, by the fact that you're collecting data, that the previous time issues and the GPS issues were resolved satisfactorily.
That's the last thing I'm working on the digital RF board. Is we're looking at a module made by Jackson Labs to provide the frequency standard. It turns out U-Blocks with its frequency skipping or pulse skipping is not going to be adequate. And my work with the Tangerine team that was doing the RF deck, what they provided me is showing some arbitrary idiosyncrasies of using the U-Blocks that contaminate the purity of the output frequency. And since we are doing frequency determination by energy and FFT bins, those little blips that show up more than once a second are going to perturb our frequency measure algorithm. So plus the fact that what I'm sort of seeing is I've got probably a second, maybe a 3rd generation prototype, but it's really not working well yet, reliably. And it's also running off of a Arduino Nano 33 IoT board. And they're having problems with it maintaining Wi-Fi, which is how they're serving a web page to run it, which we can't do. And it also means we would have a software effort, which impacts Bill Blackwell significantly. And I don't want to do that because you have to be able to control all of the loop to basically tune and damp. It's basically you're designing a Leo Bodnar GPSDO is what it boils down to. And we don't have the time, money, or enough the personnel to do that in real time right now. So my solution is looking at this Jackson Labs board. It was originally quoted to me by one of the sales engineers at Jackson Labs. They were $310 a piece. I asked for a formal quote and the price dropped down to $168 a piece. So right now we're looking at using those as our primary source. It'd probably be a 20 megahertz. And I feed that into the 5351s, possibly it also has the 16 megahertz PLL synthesis off of that I think we could use. But either way, that looks like the quickest and most reliable path forward without completely disrupting and setting this project on its ear. But that's the last major hurdle I'm jumping now. I've got one board on order from Jackson Labs, and once I get it in, I'm going to get it on a PC board, and we're going to start playing with it.
John, can we not use the GPS board from Tangerine?
That's exactly what I have in my hand from John Ackerman.
Right.
And the putting it on the spectrum purity thing on my Kiwi, I'm still seeing the little glitches that are big enough with the resolution. Since we're measuring to a millihertz, will contaminate the spectrum. I don't have the ability yet to see how bad the contamination is, but the problem is, like I say, there's a whole software effort behind that I don't want to put a third processor on the board, and I don't want to have to rewrite the code that they're using to run the PLL and the GPSDO that they're using.
Well, I thought that board was supposed to give a clean clock.
It was supposed to, but it still isn't.
is not, okay.
Yeah.
Unfortunately, I was
It's
afraid of
getting
that.
close, but it's not there yet. And Glenn is starting to beat me up a little bit on my requirements, and we're
Yeah,
having
no, John was hoping that he
yeah,
could
it
get
looks like
away
he
with
was
that.
hoping that I was going to be able to finish it for him, and if it was probably another 6 months down in the development cycle, but it looks like this, once Tangerine sort of went belly up, they sort of dropped it, and they're actively looking at it again and doing things. But what I'm seeing is typical of like a second turn prototype. It's just not ready for prime time yet.
Right. But I know John had done a
John has done
carrier board for that.
Yeah, he's done a ton of work on that. I've got the carrier board in my possession. It's running on my bench right now, and that's how I was able to do a spectrum look at it on the spectrum analyzer on the Kiwi. The phase spin on that is phenomenal. It stayed in the same exact degree position for 2.5 days. So it is dead nuts on frequency wise, but the spectrum splatter I'm seeing is of concern to me, and I can't say yes, it will work, or no, it will not work. But being that the frequency per division was 10 hertz, and I'm seeing spikes on that, and we want to measure to a millihertz, that's 4 orders of magnitude higher, and I can't imagine it not causing a splattering of our power distribution.
Right.
And that's
yeah. Well, I will say that I was concerned about that talking with John when he was designing it. He thought that
the way they're doing it is
it.
clever, but it's, I don't know. Glenn seems fixated on using a 37-cent crystal. For $2.47, you can get a voltage controlled, temperature compensated crystal oscillator.
Yes, I use those.
And for $2.50 for a board for something with the U blocks on it, that's a no-brainer to me.
Yeah, and especially for the high-end version.
We're not making 10,000 of these a month. We're probably making 100 a year.
Yeah, the
and
VCT
completely different paradigm.
Yeah, I should have fed it into a VCT CX. So
exactly.
So that's not available as a footprint on the board.
I don't know. Like I say, I was just looking at the bigger picture of, did it give me what I wanted?
Right.
And the amount of effort it would take to get that onto the Grape 2 control deck is right now a little bit too heavy of a lift, especially for Bill, because that's a complete rewrite of the software. Right. And I don't want to do that. We just don't have, we have to have this deployed by the end of the year. And I'm pushing as hard as I can, but that would put me back into a 90-hour-a-week mode for probably 6 months. And
Are you trying to avoid the ones that are generally available on the market because they put 10 megahertz out?
Actually, the one I got from him was putting either 20 or 25 out. You can actually choose that and divide it down. There's some caveats with the frequency, but they're not doing 10.
Yeah, I'm just saying there's a lot of 10 megahertz GPS
there are a lot of 10s,
out
but
there.
I'm staying away from that for obvious reasons. So
that's what I'm saying.
Yeah.
But a lot of us have that in our shacks.
Yeah. I've got multiple 10 megahertz references running in my shack, and I don't have problems, but I've done a meticulous job of doing correct grounding with a star point and a real ground rod and all that kind of stuff. So I don't have that. I don't have the pollution issues that a lot of other people have, but I've taken a lot of effort to get rid of it. So,
well, I guess maybe one thing I'm suggesting is that if you incorporated a particular module into your design with the proper grounding and all, you might be able to control the 10 megahertz pollution.
Right. But again, the bigger issue from taking it from a 10,000 foot level is right now, time is my enemy. And I can do the development and make it work, but it's not going to be in time to get these boards out. So my back's against the wall. I didn't expect the U-Blocks thing to blow up in my face. It did. And I'm recovering from that now. So I'm trying to keep myself on track here.
I forget, does the 5351 take a 10 megahertz as an option?
It takes, their website expects you to put in either 25 or 27 megahertz.
Right.
Their spec sheet doesn't want you going below a certain frequency, but I'm driving analog input directly, and I'm running at 8 with no problem. So I'm probably going to try and run it at 16 with
Yeah.
the
I'm not sure
One
whether-
other thing I
I'm
I'll
not sure
suggest-
whether they're still available, but the 5153 or 5351 Charlie allows you to use different frequencies.
Okay.
Yeah, there are different versions of that. The other thing
Yeah.
I've got a little TI synthesizer chip that I use,
Hmm.
the CDC E913 or 925, whether you want one or two different PLLs in it. That's very effective at taking 10 megahertz in and moving it where you need to. I'm running ours AMD Doppler receiver, generating a 28.8 for the RTL SDR and a 129.6, which is harmonically related for the up converter.
Mhm.
Seems to be clean enough. And certainly if you're feeding into a 5351, that would clean up whatever residual is there. So it's just one little tiny 8-pin chip. Or
Yeah,
well,
I've
it's
got
not
two-
8-pin, but it's an SOIC.
Right. I've got two 5351s on
Yes,
the
SOP.
Grape 2 control deck, and it's creating the 3 frequencies and then my test port.
Yeah. So I'm
And-
just saying that would be a cheap way to go from a 10 megahertz
Yeah.
generic GPSTO and make
But
the
being that we can feed the
5351s happy.
5351s with any frequency, and then we just change the division ratio numbers
Right.
to Bill Blackwell's special math wizard, commonly known as his wife. We can get some very good numbers that don't have the skip numbers in them, so they're dead nuts on. So,
right,
we're probably going through that again now, since we have the option of choosing either 16 or 20 for feeding the signal chain. So, I'll have to. We're going to have conversations about that once we get a little bit closer. Once I determine this Jackson Labs solution is viable, then we'll move ahead. But until I get to that point, I'm not going to push any buttons on changing anything there on that yet. So
I would
that's where
like.
I stand. Back to net, and we're late.
Okay. Just because it's not something we can necessarily resolve, and if you have strong opinions on it, perhaps we can discuss it at a later point.
Yeah, it's a work in progress.
Actually, check the Jackson Lab stuff. Kong, are there any software updates you'd like to talk about briefly?
So John basically already gave an update of everything that I did this week, but what I can do, I can show some quick. Can I share my screen?
Yes.
So I can show the content of the files that John was showing. So this is the raw data file with all the necessary information, the metadata, and down here we have the timestamp and the data from the 3 radio channels. And at the end of each of the packet will be a checksum. So my next task will be making sure that the checksums are correct before I actually write to these files. And then the other file, this is after the frequency analysis has been done on the raw data file, and it will be separated into 3 different files for each of the channel. I mean, each of the beacons. So this is the beacon number 1 with the timestamp for each of the data packet and the frequency and the amplitude. And similarly, I have another one for beacon number 2 and another one for beacon number 3. You can see the data is
it's big.
artificial right now. So after
And what's actually going to happen is we're going to give you the exact offset frequency to be added to that 600 number to come up with the 15 megahertz number. So that number is going to be 15 megahertz, 0.00 something. And then the amplitude will be between 0 and 2. So the 600 is just the offset that we're actually measuring due to the mixing. But we have to come up, once we know the division ratios from the PLLs, we know exactly what we're injecting and what we're mixing and what the difference frequency will be. And then we'll add that number to what we measure to come up with the exact frequency of the beacon. So this 600 and the 2 are just temporary numbers that David put in as space holders to get the plumbing for talking to the talking to his subroutine correct, and you obviously have it working perfectly. So in theory, all he does is he gives us the new module, and all of a sudden we get the real numbers. So, and David is working on it very, very diligently. He had it working and then he broke it, and then, but that's part of development. So when he gets it ready, we'll pop that in, and then Chung Kung, I'll get you the information on what we need to create the final number for the frequency.
Okay, that sounds good.
It's going to be a simple addition to a fixed offset for based on one of the 6 beacon frequencies. Will give you 6 numbers. So if you have WW15, you'll be adding 14.99500.236 or something, whatever it works out to be exactly, so we can nail the frequency dead nuts on with our PLL. So
That sounds good.
yeah,
Yeah.
a simple change, but, and there's the magnetometer one. And we do have a local temp sensor, which is going to be measuring the GPSDO temperature so we can track it. The magnet temp is going to have the temperature sensor out on the mag temp board. And then there's the 3 magnetic flux vector, or I'm sorry, scalar numbers in nanoteslas. And that'll show up once a second.
Yikes.
And I did not see the need to create the composite vector of MX, MY, and MZ, because you can do that with the data, and storing that just takes up extra space. So my philosophy is, if you can create the number from the data that's there, you don't need to store it. Which is why I'm not storing frequency error in the previous 3 files, because you can calculate what that should be too, because you know what it's supposed to be. We don't want to, make the data set fatter than it needs to be. But this will allow us to track temperature as well for the GPSDO as well as the outside magnetometer. Since the magnetometer has ferrites in its magnetic sensing electronics, the TempCo of the ferrite has enough gain that it makes a very good temperature sensor, unfortunately. That's the voice of experience. I've worked with this kind of ferrite stuff before, and it does have a significant TempCo. Anyway, back to net. I'm killing the time here. I'm really feeling guilty here.
I think we can end it there. Gary, do you mind doing I know you worked on website updates. Would you mind sharing them next week?
No, that shouldn't be a problem at all.
May I make an announcement?
Go right ahead.
Okay. From the NASA administration point of view, PR people, I just got this email asking to have a plan to capture pictures of people during our project. So obviously our project is very large and involves lots of people, but so if you are participating in the solar eclipse QSO party, or if you're just like watering your grape, whatever it is you're doing, if you would mind taking some photos. It says if you get someone who's under 13, you need your parents' permission. If you get someone else's permission photo, you might need to get their permission. Probably after the eclipse, either I or Gary will send an email out on on the Hamside Google group and ask people to fill out a form and upload their photos that might get used by NASA or somebody else. So just keep that in mind.
All right.
And
all right.
Again, thank you, John. Thank you and Kung, and Bill Blackwell and everyone else. Thank you for all those great efforts and progress on the Grape too. That's very exciting.
Yes. And at least for Grape pictures, you can also put them in next week's minutes. It's already linked at the top of these minutes. So just throw those in. Very cute Grape pictures, eclipse pictures, Grape eclipse pictures. And I think with that, I'm going to call a close unless anybody has pressing comments, concerns, or announcements.
Can you email me the link for that status file? I think it's in a Google Docs or some shareable place for me to put pictures.
Oh, it's at the top of the minutes.
Oh,
it's next week's minutes. I think it's a fair place to arrow.
The link to the minutes, I guess, is what I'm asking for.
Yeah, it's this one. Next week's minutes.
Yeah, how do you get to that?
You click the link. And then it
Well, I
takes you-
can't click the link.
Oh, can you not?
No,
No, you're doing a screen share.
Well, oh, but
I can see what you're doing, but I can't do anything on your page. I'm not logged into you.
an
You mean
email?
the link to the minutes we need, that's all.
Yeah.
Yeah.
Oh, I thought you were getting them in the announcement emails. I'm sorry, I'll check.
I probably, if they are there, then don't worry about it. I just don't remember seeing it.
I'll
they're
share.
there. Yeah, they're in the announcement email.
Okay, never
Yeah.
mind. My
Very-
bad.
But I will share this one just in case. Oops.
Nathaniel, did you get my second email?
I did, and it was great. Thank you very much.
Okay, so you got the form.
I have the form. I see your signature. I'm going to try to appease the Frontiers administration. Yeah.
Good luck with that.
Thank you.
They are difficult to appease.
They are a difficult bunch.
Rachel, I'll admit that this problem was called a picnic problem in share, not in computer. Sorry.
You're fine. Okay. I think I do have to go to class. If all of you would like to stay around, you may do so. I'm going to go ahead and stop the recording.